If we wrap up the things like in unit 2 and unit 3, in unit 2, the first one is inequalities. Inequalities. This is the first topic. And the next one is the modes of convergence. Modes of convergence. Hello everyone. Welcome back to our channel. So in this today's video, we are going to learn what are the expected questions or previous year question papers by analyzing them. Here I have summarized the questions expected for the long questions in applied probability theory MSc semester 1. So let us start with the unit 2. Let us see this unit 1 in the last, but let us start with unit 2 and unit 3. In the unit 2, we have the 7 inequalities, right? So, without these inequalities, there will be a no question paper. Listen properly. You have to learn the 7 inequalities. Without this inequality, there is no question paper till now. So that please try to learn all this Chebyshev's, Markov, Cauchy's, Holder inequality, Minkowski and Jensen inequality, Lyapunov. And they may ask the question like this also, like what is the interrelationship between the Chebyshev's inequality and the Markov inequality? What are the applications, advantages, disadvantages, and derive the Chebyshev's inequality or derive the Markov inequality? Or they may ask the question also related to individual question for Chebyshev's inequality, like to solve the problem. So hope you should learn the what is this inequality and where should it be used, and the problems and the application and how it is related to the other inequalities. And for all these inequalities, I have made a detailed video for each of the inequalities. I will ping the or I'll give the link in the description box. Please go through and watch. And the next topic you need to learn in the unit 2 is modes of convergence. There are 4 types of modes of convergence, right? Which is convergent in probability, almost sure, and quadratic mean, and log. This table is very important, and their interrelationships. How convergent in almost sure? If it is convergent in almost sure, then it will convergent in log. These are the interrelationships you need to learn. And all the interrelationships also I have made a detailed video, so please go through and watch it in a playlist of applied probability theory. And the next one is the Slutsky theorem. This is the important one theorem. It is expected for the long answer questions. Whatever I have told now from beginning till now, those are for the long answer type questions. So please carefully listen to the video, watch the video without skipping. And next one is the statement of Glevenko-Cantil lemma. This may be asked for the short answer type question. And here if you see, I have the notes like if xn is convergent in x in rth mean, then show that xn is convergent to x in probability. This is the proof. This is the theorem statement and this is the proof. In this way, you need to learn the interrelationships. If you remember this one, then you can easily learn the interrelationship between modes of convergence. This is the easiest way to learn. And the Borel-01 law, which is asked for the long answer type question. This is the theorem. That in previously I have spoke about the problems, right? In this way, the problems may be asked. If P of xn is equals to 0, the probability of xn is equals to 0 is this one, and the probability of xn is equals to 1 is this one, then examine whether the sequence holds convergence in probability or not. These type of problems may be asked for the long answer type questions. Like they will give an inequality to prove and they will give like one problem. It is like question 7 and in that A part and a B part. So you will get a total score when you answer for A and B. Okay, and this is the another question. Whatever the problems I'm showing here, these are the questions which are asked in the previous year question papers. So please make a note of it and find out the answers by yourself. Now let us see what are the expected questions from Unit 3. And Unit 2 and Unit 3 are related. Like if you learn Unit 2, then the Unit 3 will be easy. Okay, they are like interrelated concept. So in Unit 3 is most you have to learn about the weak law of large numbers. What modes of convergence comes under weak law of large numbers, what modes of convergence comes under strong law of large numbers, and so that they have the defined theorems in that one. For weak law of large numbers, there are some theorems, and strong law of large numbers, there are some theorems like Bernoulli weak law of large numbers, Chebyshev's weak law of large numbers, Kington's weak law of large numbers, and Borel is in both, like strong law of large numbers and weak law of large numbers. So if they ask specified like Borel's strong law or Borel's weak law, you need to write only those proofs of, and Kolmogorov inequality, and strong law of large numbers, Kolmogorov, IID case. Some are the ID case, independent case, and some are the identically independent case, and Borel's strong law of large numbers. Borel is in both, as I said before, it is in both. And in the same unit, the first topic is law of large numbers, which includes of both strong law and weak law, and what are the modes of convergence comes under strong law and weak law, their respective theorems. Then the next topic is central limit theorem. In central limit theorem, there are like 4 theorems, I think so. So first learn about the central limit theorem, what is meant by central limit theorem, and what are the importance of central limit theorem. And the first theorem is de Moivre-Laplace form of central limit theorem. Sometimes they mention the name of the central limit theorem, but sometimes they will give only the statement. You have to identify whether which central limit theorem they are saying. So you need to learn both statement and a proof. And the next one is Levy-Lindenberg form of central limit theorem. I think so this is the theorem most asked or expected. This theorem. They'll give the statement, you need to identify which form of central limit theorem they are saying about. So according to that, you can answer the proof. And the next one is Lindenberg-Filler. That is, second theorem is Levy-Lindenberg. This is Lindenberg-Filler. So don't confuse of the names, and try to learn the statements, like understand them without by heading, so that you don't confuse between the statements of two, Levy-Lindenberg and Lindenberg-Filler. And the last one is Liebman of central limit theorem. For this we only have the statement. They don't ask for the proof, so they'll ask only for the statement. So if we wrap up the things like in Unit 2 and Unit 3, in Unit 2 we have only the 2 topics. The first one is inequalities. This is the first topic. And the next one is the modes of convergence. And the next one is Slutsky theorem. And the third one is Borel 01 law and Levinko-Cantilli lemma. These are the 5 topics, right? Inequalities, which means the 7 inequalities, their interrelationships, their applications, and related problems. And in modes of convergence also, 4 types of modes of convergence and their interrelationship and their application. their problems, and the Slutsky theorem. It is a one and Borel 01 law and Glencoe-Cantil lemma and related applications. If you cover 1, 2, 3, 4, 5 topics, then Unit 2 is completed. And in Unit 3, you need to cover law of large numbers. Law of large numbers and central limit theorem. Central limit theorems. Which means in law of large numbers we have both strong law of large numbers and weak law of large numbers. What comes under strong law of large numbers? What comes under weak law of large numbers? Their respective theorems. Like Khinchin's, Borel, Chebyshev's, IID case. And in central limit theorem, what is meant by central limit theorem and importance of central limit theorem, or we can call it as applications and 4 types of central limit theorem. De Moivre-Laplace, Levy-Lendenberg-Filler, and Lyapunov. That's it. And some of the related problems also. And if you cover these 2 topics, then Unit 3 is completed. This is how you need to wrap up the Unit 2 and Unit 3. Now let us see for the Unit 1. In Unit 1, you need to cover the conditional expectation and conditional variance. There are the 4 theorems in this one. First, you need to understand what is meant by conditional expectation and conditional variance and what is the double E rule. These question is most repeated one, this theorem. This double E rule of expectation. Theorem on conditional variance. They may ask what is the relationship between the conditional variance and conditional expectation. So for that one, the answer is you need to write this theorem statement and the relationship between conditional variance and conditional expectation. And these are the problems related to conditional expectation. So you need to learn or how to solve the problems of conditional expectation and conditional variance. So these are the problems. This is the first problem and this is the second one. And that's it about the conditional expectation and conditional variance theorems and problem. And in the Unit 1, the inversion theorem, it may be expected for the long answer type, and uniqueness theorem. And the another long question from the Unit 1 is explain the characteristic function and the properties. They will give like this one, and whether this is a characteristic function or not, you need to prove by inversion theorem or any by the another theorem. They will give the problems like this. This is expected for the long answer type question from Unit 1. And these are the other question. Example 2 and example 3 and example 5 and example 6. Here see, if x is a discrete random variable, and having PMF, find it by using phi x of t is equals to p into 1 minus q e to the power of it whole to the power of minus 1. Find the characteristic function. And the another question, if x is a random variable and having the characteristic function phi x of t, this is the phi x of t, then what is the PDF? And if we wrap up the Unit 1, that is from Unit 1, you may get questions from conditional expectation, long answer question, conditional expectation, conditional variance, and the uniqueness theorem, inversion theorem, and about the characteristic function and the problems. And this you need to cover from the unit 1 so that you have an whole idea of unit 2, unit 3 and unit 1. And in the semester 1 for the applied probability theory there is a vast syllabus, so please try to uh, complete the syllabus as soon as possible so that you will get enough time to revise what you have learned. And this is the previous year question paper. This is the backlog paper, I think so. And first let us see the long answer type question. Show that the set of discontinuous of any cumulative distribution function is almost at most countable. And this is the most important question in the unit 1, the sixth question. And if you see, evaluate the probability function. Right, this is the problem given from unit 1. And the second one, if you see, state and prove Cauchy-Schwarz inequality and writes its application. Okay. And the B is, if xn is convergent in x with the probability is a continuous function defined on a real set, then prove that this is the properties. This is the properties of Glevenko-Cantelli lemma, I think so. Just once check the properties also. And from 8th question, this is from unit 3. Show that it holds the strong law of large numbers. I think so. This is one of the integrable independent random variables. This is the theorem from strong law of large numbers. It may be Hinton's or Borel's, I don't know. Just check it. And this is from the central limit theorem. They have given the problem. You have to examine whether this f of x holds central limit theorem or not. 8th question. And ninth one is the state and prove Borel 01 law and write it importance. And this is the problem from the characteristic function. First unit. And the last one is, this is the problem from weak law of large numbers. And these also the same, I think. So the last one. Show that the convergence in law. This is the IID case and we have to show whether this is convergent in law or not. This is the backlog paper, and if you see here, the short answer type questions define the conditional expectation, state Jensen inequality and write one of its applications, leap one of central limit theorem. These are the direct questions, right? State the properties of a characteristic function, Glevenko-Cantelli lemma. So this is the backlog paper, and the short questions are quite easy. But when it comes to the long answer, it is most of the problems, right? So try to clear your exams in a regular only. Don't put it as a backlog. And I'll show you the regular paper also. And this is the regular paper. Regular paper is February, March, and backlog paper is 2025 September. Let us see first long answers. First question, show that the distribution function satisfies the properties f of minus infinity 0 and f of plus infinity 1. The distribution functions, this is the degree question. If you see, and I'll show you the answer also if I can. And this is the answer for that one. And the sixth only, the big question, state and prove uniqueness theorem of characteristic function and evaluate density function whose characteristic function is this one. I said you before, like in the characteristic function, they may ask the questions also, problems also. Okay? And seventh question, state and prove Minkowski-Jensen inequality and write on each any two of their applications or uses. And now, the B question is like problem. Show that convergence in probability does not imply convergence in almost sure. It is a counter implication. We have implications and counter implications. This is the counter implication. And they have given, if you see, this is the A part, in B only, the first part and the second part. If you answer the both, then only the full marks are awarded. Right? So if you have completed learning the theorems, try to learn solving the problems related to topics. Okay. And the eighth one, Kolmogorov strong law of large numbers. This is the independent case, and below is the problem. For every question, there is a problem. If you see 8th B also, Levy-Lindenberg central limit theorem, and there is a problem. And the ninth question, state and prove Borel 01 law. And B question, it is uniform priori distribution. It is from unit 1. And Bose-Einstein, it is also from unit 1. Okay. And the 10th question, this is a relationship between the conditional variance and conditional expectation. And there is a theorem and there is a problem here. Okay. And the last one is show that convergence in probability implies convergence in law. This is the implications. This is a very easy paper, right? If you compare with the backlog paper, just we have seen before. And here, if we see the short questions, define probability as a measure and necessary conditions to hold convergence in probability, and state the Lindenberg-Feller central limit theorem, Glevenko-Cantelli lemma, and importance and need of the characteristic function. That's it. This is of the regular paper. Hope you understood the difference between the backlog and a regular paper. And if I have any previous year question papers, I'll share with you. And thank you. Happy learning to you.